Hello, this is the section 4.1 to 4.2 lesson. In chapter 3 we started talking about addition and subtraction. In this chapter we're going to start talking about our next type of arithmetic, namely multiplication. And so section 4.1 we're going to talk about in multiplication, what does it mean, how are we going to interpret it, how are we going to set it up. And then section 4.2 is very short. We're going to talk about why multiplying by 10 is very easy, and then how to do it. So let's start off with a simple example that's going to motivate a couple of different interpretations of multiplication. So question, how many dots are in this picture below? Well, we could obviously count them, and we could see we'd have 10 dots there. So that's easy to do. Another way to do it is to say that, well, right here I've got 2 dots, and then 2 dots, and 2 dots, and 2 dots, and 2 dots. So we could take 2 plus 2 plus 2 plus 2 plus 2, one more time. And so then we add all those together and we get 10. So that's one way to do it. Just add 2 to itself 5 times. Another way, if you remember back from elementary school, we said that multiplication was repeated addition. So we could say that we've got 5 times 2 equals 10. So there's another way that we could represent the solution to this problem. Okay. So this illustrates one interpretation of multiplication. We solve this by taking 5 times 2 and we get 10. We can interpret this as that we add 2 to itself 5 times. 2 plus 2 plus 2 plus 2 5 different times is equal to 10. So that's one interpretation of multiplication. Multiplication can mean repeated addition. But let's look at another interpretation of this problem. So same question, how many dots are below? We've already concluded that the answer is 5 times 2 equals 10. Well, let's look at a different interpretation of these numbers 5 and 2. And so we see that we've got our dots here. They kind of come in groups of 2 like this. So let's circle those groups. Here's one group, here's a second group, a third group, a fourth group, and a fifth group. And so the 5 here is like a number of groups. And then the 2, where did the 2 come from? Well, the 2 was the number of dots that we had in each one of those groups. So number of groups times the number of items in a group. And so that's what the 5 represents, that's what the 2 represents. And then what does the 10 represent? Well, 10 is the total number of dots, or total number of items. And so this equals the total number of items. So that's what the 10 represents. So this interpretation illustrates this meaning of multiplication that we're going to use throughout the rest of the semester whenever we talk about multiplication. Multiplication looks like this: A times B, so some number times some other number equals C. The first number, A, is going to represent a number of groups. The second number is going to represent the number of items in a group. And then the number C is going to represent the total number of items. These numbers A and B are generically called factors, and the number C is called a product. So to use this interpretation of multiplication to solve a multiplication problem, we're going to ask ourselves the following 4 questions. A, what is an item? And sometimes to answer that we have to look at the question being asked in the word problem. What is an item? Second question, what is a group? Third question, how many groups do we have? And then the last question, how many items are in a group? And so then the solution to the problem is we're going to take the number of groups that we have in part C and take that times the number of items in a group, and that's going to give us our solution. Okay. So let's illustrate this with a couple of examples here. So 4 cars sitting at an intersection contain 3 people each. How many total people are in the car? So let's draw a little strip diagram to illustrate this scenario. So let's draw one car here, that has 3 people, and then we have another car which has another 3 people, and then another car which has 3 people, and then our 4th car which also has 3 people. So there's a simple problem or simple strip diagram that illustrates what's going on. Now obviously we could count the number of people. We'd have 3, 6, 9, 12. So there's our answer, but let's look at how we can set this up as a multiplication problem. Okay. So the first question, what is an item? Well, to get the item, we need to look at the question being asked in the problem. So how many total people are in the car? So an item is people or person. Okay. Now, what is a group? Well, we see from our picture that we've got a group of people here, 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 and here. Each one of those groups is a car, so a group is a car. So how many groups do we have? Well, we see that we have 4 groups. How many items are in a group? So we have 3. And so our answer, our solution to the problem is the answer to part C, which is 4, times the answer to part D, which is 3. So 4 times 3 equals 12. And so there's our answer. 4 groups, each group contains 3 people. 4 times 3 is 12. There's our answer. So let's look at a simple geometric problem. How many small squares are in the figure below? So by small square I mean one of these or these or these or these. So we could obviously count these and we'd have 12 squares, but let's look at how we could set this up. Okay. And so the first question, what is an item? Well, our question is asking how many small squares are there, so an item is a small square. Now, second question, what is a group? Well, a group isn't quite as clearly identified in this problem as it is in the first problem, and there's actually a couple of different ways that we could look at this. One way to look at this is let's take like a row here as being a group of squares. So there's one group, and there's a second group, and there's a third group. Okay, so what is a group? Well, a group is a row of squares. How many groups do we have? Well, there's 3 groups. How many squares are in each one of those rows? Well, there's 4. And so then the answer is, well, we have 3 groups times 4 squares in each group. 3 times 4 is equal to 12. So there's our answer in terms of multiplication. Okay. Now, another way that we could have interpreted this problem is to, in part B, when it says what is a group, we interpret that as a row. Well, we could have also interpreted it as a column like this. So we have 1 column, 2 columns, 3 columns, 4 columns. Sorry, the problem there is a little bit easy, or the picture is a little hard to read, but what is a group? We could also interpret a group as a column. So then how many groups do we have? Well, we have 4 columns. And then how many items are in a group? So that would be 3. And so in that interpretation we have 4 groups times 3 items in each group, and we still have the same number of items, which is 12. So 4 times 3 equals 12. And so there's another way that we could have set up this problem. Now this problem also illustrates a property of multiplication that we're going to talk about in the next section, but we won't get into that right now. Alright, so let's look at another type of problem. John has a collection of 3 marbles. Ed has 4 times as many marbles as John. How many marbles does Ed have? And so let's draw a picture here of what's going on. So let's draw a strip diagram. John has a collection of 3 marbles. So let's draw a strip here to represent John's collection of 3 marbles. Now Ed has 4 times as many, so that means that Ed has 4 of these collections. So let's draw 3 more boxes there. 3, 3, 3. So there's a picture, and so now let's answer our questions. Number 1, what is an item? Well, the question asks how many marbles does Ed have? So an item is a marble. Okay. So what is a group? Well, a group is one of these boxes which represented the collection of marbles. The collection. How many groups do we have? Well, there's 4 groups. How many items are in a group? Well, there's 3 marbles in each group. And so now we set this up. We see that we have 4 groups of 3. 4 times 3 equals 12. So there's our answer. Now, this type of problem where we see that someone has like 4 times as many as someone else, something to that effect, is what we call a multiplicative comparison problem. A multiplicative comparison problem. Okay. It's called multiplicative comparison because in our problem we are comparing the number that one person has to the number that another person has. Multiplicative because we're making that comparison with multiplication. Now, one thing I forgot to mention about the previous problem is that in that previous problem we had a picture where things were arranged in rows and columns. A problem like that is what we call an array problem. Now, the book will talk more about these different types of problems, and it'll talk about some other types of problems, but kind of the 2 most common types that we're going to deal with in this class are the array problems, where things are arranged in rows and columns, and then this multiplicative comparison problem. Okay. So let's look at another example, and we're going to use this example to illustrate a bigger point about multiplying by 10. So Kayla has 10 bundles of toothpicks. If each bundle contains 34 toothpicks, how many total toothpicks does Kayla have? Okay. We're not going to draw a picture of this, or we'll see a picture on the next couple of slides, but let's just set this up by asking our questions. Okay. So first question was an item. Well, if we look at the question, it says how many total toothpicks does Kayla have? So an item is a toothpick. Okay. Now, what is a group? Well, it says that we've got these toothpicks arranged in bundles, so a group is the same as a bundle. And then how many groups do we have? Well, we're told that we had 10 bundles. And then how many items are in a group? Well, we're told that each bundle contains 34. And so by our meaning of multiplication, we have 10 groups and 34 items in a group. And so 10 times 34. Now, we all remember from elementary school that multiplying by 10 is easy. We often thought of the rule of multiplying by 10 by simply saying that we add a 0 to the end. So this would be 340. So there's our answer. We simply added a 0 to the end of the number 34. Now, next we want to talk about why does that work? Why can we just add a 0 to the end? And then we also want to talk about maybe a better way of explaining that rule. Okay. So to illustrate why we put a 0 at the end, and a different way of looking at this rule, let's look at this picture of this scenario. So here we have one of these is a single toothpick, and then this right here is a bundle of 10 toothpicks. So the number 34 means we have 3 bundles of 10 and then 4 individual toothpicks. Okay. So there's one bundle or one group of 34 toothpicks. There's another, so on and so forth. Okay. So we've got 10 of those. You can check there that we've got our 34 bundles. And so this right here is the total number of toothpicks that we have. Well, to organize this picture better, we like to group things in groups of 10. And so let's start on the right here, and notice that in this rightmost column we've got 10 toothpicks right there. So let's kind of bundle those together to form a bundle of 10. Likewise, let's bundle these together to form another bundle of 10, and then bundle these together to get a bundle of 10, and then these to get another bundle of 10. So we get 4 different bundles of 10 there. Now let's look at these bundles of 10 over here. Notice that right here we have 10 bundles of 10. So let's bundle those together to form a bundle of 100. And then let's bundle these together to form another bundle of 100, and then these together to form yet another bundle of 100. So once we bundle all these together, we're going to have 3 bundles of 100 and then 4 bundles of 10. So let's kind of draw that down here. This is what we get when we've kind of bundled everything together. And so we can think of this as though, like, this last column, which formed one bundle of 10, that gets moved over here. This next column, that got moved over there. This column got moved over there. And then this got moved over here. Now, these bundles of 10 that were here, they got moved over here to form a bundle of 100. Those got moved over there to form another bundle of 100. And then these got moved over here to form another bundle of 100. And so what we see here is that when we organize things, when we rebundled things according to bundles of 10 or 100, basically all these bundles of 10 got moved over here to form bundles of 100. All these individual toothpicks got moved over to form bundles of 10. And so we can kind of illustrate what happened here with this picture. We see that the three that we'd had these originally 3 bundles of 10 in each one of our groups. That got moved over to the hundreds place. And then we had, in each bundle, we had 4 individual toothpicks, and so they got moved over to the tens place. And so this illustrates kind of a little more generic way of describing multiplying by 10, in that when we multiply by 10, we want to move each digit one place to the left. And so the 3 is going to get moved from the tens to the hundreds place, the 4 gets moved from the ones to the tens, and so 10 times 34 equals 340. We didn't simply add a 0 to the end, we moved each digit one place to the left. Now, why might I describe it in this way here rather than just say that we add a 0 to the end? Well, let's look at an example dealing with decimals. Calculate 10 times 0.034. Now, if I remember the rule by simply saying that we add a 0 to the end, then I would say that this equals 0.0340. Right? I added a 0 to the end, but that number here isn't any different than this number here. So that's not the correct way of doing it. We followed the rule, we added a 0 to the end, but that rule stated in that form doesn't apply to decimals. It only applies to whole numbers. When we state rules, we want to make them as generic as possible. We don't want to state one rule for whole numbers and then another rule for decimals and then another rule for this type of numbers. We want to try to state rules that apply to all numbers. And so this rule of moving each digit one place to the left applies to whole numbers. It also applies to decimals. And so this 3 that was in the hundredths digit is going to get moved over to the tenths digit. The 4 that was in the thousandths is going to get moved over to the tenths place. And so 10 times 0.034 is going to be 0.34. And we could add a 0 on the end if we wanted to, but that's not really necessary. So there we go. There's our answer. We moved each digit one place to the left, and we got 0.34. So there we go. That's it for this lesson. Your assignment before next class period is to read sections 4.1 to 4.2 from the textbook.